Hello, CCR students. My name is Mr. Tasker, and today we're going over inferring answers from systems of equations. Please grab a whiteboard and turn in your cumulative review if you are done with it, and then complete your bell work, and we will get started. If you have any questions to go over the bell work with your teacher, please feel free to ask questions now. Pause the video, and then you can come back. Okay, for our warm-up activity, we were asked to find this emoji puzzle and solve it. I think this is a good brain activity and a good way to sort of get you in the idea of thinking about how to solve these systems of equations. Because this is really just a system with three variables. We have to figure out what each of these emojis means in order to solve our final question right here. I have three smiley faces, or winky faces, whatever you want to call them. Each winky face, when added together, is equal to 30. So if I divide this by 3, I get the value of just one winky face. I split it into 3 parts. So I think about what does this equal to make 30, right? I can think about this as 3x is equal to 30. To get x, I divide by 3, and that gives me that x is equal to 10, or what our winky face is 10. If we decide to call our double face, for instance, maybe y, we have y plus our winky face again, which we already named x, which is equal to 25, right? Well, we know that our winky face is 10, and that is equal to 25. We can rewrite this as y plus 20 equals 25, and I can solve that by subtracting 20 on both sides. That means that y is equal to 5. So our devil face is equal to 5. In our third one, we have our hard eyes. We'll just call that z. And we have z plus our devil head, which is y, right? And that is equal to 17. Well, we know that our devil face now is worth 5 points apiece. So we have z plus 5 equals 17. That's the same as z plus 10 is equal to 17. And when we subtract 10 from both sides to isolate our variable, we get that z is equal to 7. For our final equation, we can just take what we've been doing and then plug in our numbers. We have 2 hearts, which we've called z, plus 1 devil head, which is a y, times 2 of these winky faces, which we have named x. And I'm sorry if my z's and my 2's look very similar. It's a problem I struggle with daily. So really, we can write this equation as 2z plus y times 2x equals what? Right? Well, now we just plug in what our variables are, right? If we remember, z is our hearts. We can do this right here to help remind us. Z is our hearts, so that is 2 times 7 plus y, which is 5, times 2, x. X is 10. Now we just follow our order of operations. 2 times 10 is 20, times 5, plus 2 times 14. 7 is 14. We have to multiply first. 5 times 20 is 100. Our 14 is still here. And what do we end up with? 114. Fun times. So what is a system? A system is what we're going to be talking about for the next foreseeable future. A system is 2 or more equations that share variables. Visually, what this means is 2 or more lines. So in these equations, we are asked to find how many equations we see in each line or each graph, and one line is going to be one graph. So I have one line, I have another line here. This one has 2 equations. I have 1, 2, and then 3 lines here. So this has 3 equations. I have 1 here, and then 2 here. This is the same line. So I only have 2 lines. This is a parabola, so I have 2 equations. And then in here I have 2 lines. Right here I have 1 and 2. These are 2 separate lines, so they must be 2 separate equations. So to see if something is a system, we look at how many lines it has. What does a solution mean? Well, a solution to a system must satisfy all of the equations in our system. That means that there is a point where all of our lines meet, right? There are 3 types. Oh, these are mislabeled. 1, 2, and 3. We'll call that right here. Any and all points that work in all equations is an answer, is a solution. The number of points is the number of solutions. So if I have 1 point that satisfies all of my solutions, or all of my equations, that is 1 solution, right? Where all of my lines meet. If I have 2 points where all of my lines meet, we have 2 solutions, and so on and so forth. If there are no points where your system works, then there is no solution to that system. And if, for instance, God forbid, there are an infinite number of solutions, then we say there are infinite many solutions to that system. A solution occurs when all the lines meet those points, right? Visually, what this means is, where do our lines touch? I have 2 lines here, 1 and 2, right here, and they touch right here. That is a solution to our system. It satisfies both values, or both equations for this value. In our second set, we see that 1, 2, 3, 4. This is where they all touch, right? I have 1, 2 lines right here, and they all touch right here, here, and here. That means that this one has, oh, let's separate. 1 solution here. This has 4 solutions. And then in this one we have 1, 2, that is a terrible 2, 2, and 3 lines right here. And I have these points where they touch. But not all of them touch. They don't all touch at the same point, right? I have, this point has 2 and 1, line 1 and line 2 touch. This one has line 1 and line 3, and this one has line 2 and line 3. But none of these points satisfy for all 3 of my equations. That means there is no solution. I can't count this as a solution unless all of my lines touch at the same point. In my last one, it looks like I only have 1 line. And normally I would say that's not a system. But we are given the hint that they are all systems. This must be a system, right? And that means there must be at least one other line on this system. We can't see it, but what I think is going on here is there is another line hiding underneath our line. If I have 2 lines that go in the same direction at the same speed or the same slope, they will always touch. And because they're always touch, there is an infinite number of solutions to this system. There's an infinite number of points where it meets. So if I were to ask you to identify what these solutions are, not just that they are solutions, but what are they? We're going to write that as a coordinate point, an x and a y, right? So literally, we're going to look at this point, right? In my first one, I have 1 point where they meet, and I'm going to go and find out what that coordinate is. Well, I go to the left 3, -3, and then I go up 1. That means that my solution is -1, 3. Literally what that point is at. In this system, I have 2 points where they meet, right? So both of them are solutions. I have to figure out what they both are. I go -3, and then down 5, and then I go just over 2. I don't go up or down anywhere. So my first solution is -3, -5. And my second one is 2, 0, because I don't go up or down on my y-axis. In my third set, my third system here, these 2 lines will never touch. If we pay attention, they will never touch. And we've already discussed, if they never touch, then there is no solution. Right here, we are asked to sketch a graph that matches the solution to each system. And what that means is we are told that there is a system somewhere where this point is an answer to it. Well, there are a lot of different ways that you could do this. So I'm going to give you guys a second to go ahead and on your whiteboards find some possible sketches. We're not trying to be exact right here to these graphs. Go ahead and pause the video and take your shot. Okay, so for my first graph, what I came up with was these two lines right here. And you don't have to write the equations for your lines. We're just looking for a sketch. But what happens is these two lines meet at that point, 3, 2. Go ahead and take a chance at the next one. Go back to that real quick. Our second one is we have 2 points here. We have 2, 2 and negative 2, 2. So these are 2 separate points where our solutions are met, our equations are met. We're going to have to try and sketch a graph of that. So go ahead and take a shot, and then I will show you on Desmos what I ended up with. So what I ended up with is 2 parabolas. And again, our equations here are not so much as important as understanding where these lines touch, right? I have 2 points right here. One is at negative 2, 2, and one is 2 here, 2, 2 right here. And right here is where these 2 lines meet. They will never meet again. They don't meet anywhere else. So that satisfies my system. Could I have done it another way? Absolutely. I could have drawn a line that goes straight through these lines. It would have been y equals 2, and it meets these lines right here. I could add another line right here. I can actually show you y equals 2. I now have 3 lines, but they only meet here. So those are the only 2 solutions I could possibly get. So for our third one, what we're going to do is we have 3 points now, negative 5, negative 4, 2, 3, and 6, 6. And we have to come up with a solution to this, or a graph for these solutions. So go ahead and take a second and try your luck right here, and we will come back and figure it out. And rather than try to figure out a graph that is going to work for this, I decided to sketch it. I have these 3 points graphed already, and then in real time, I'm going to draw a line, just a line that comes through all these points. It's not perfect. It's going to be a little curvy right here. It's just going to curve real slow. There we go. Just one line. All right. And then I have another line that is only going to touch these points, right? I'm going to create a polynomial right here. It just goes down and then back up and then down again. Okay. This is a line. This is a line. I have 2 lines that makes a system, and they only touch on the 3 points that are listed. Does it have to be perfect? Not at all. But this is the best that I can do with the limited space that I have. And for the final one, we are told that there are no solutions to this system. I want you to go ahead and think about what that's going to look like, and then maybe graph something that could satisfy that solution set, and come back to us. And in our final no solution set, what I decided to do is just create this little Desmos thing. The important thing to note is here, I can prove that these are never going to touch because they have the exact same slope here. I have a slope of 2 in my first line and a slope of 2 in my second line. My second line starts a little higher at positive 2, whereas the intercept for this one is just 0. But because they have the same slope, they will never touch, which means there is no solution. There are a lot of different ways you could have done this. You could have made curved lines, as long as they never touch. Okay, so that is the end of our lesson here. What I would like you to do now is to move on to your Delta Math, which should be Skill 11 IP, Inferring Answers from Systems. And hopefully you have time to get that done in class. And once you are done, I look forward to seeing some of you on Friday. Have a great day.